Hello and welcome to a new video. My name is Herwig Juster and today we discuss how to improve the flow properties, chemical resistance as well as the wear resistance of amorphous resins for parts which need to have a good impact behavior, good mold flow and high dimension stability with low warpage. Okay, let us get started. To start with some words about polymer morphology. So polymer morphology describes the arrangement of polymer chains. For example, in thermoplastics, which is shown here, we have two systems, two morphologies, amorphous and semi-crystalline. We have also in elastomers, we have the chemical bonding of polymer chains, and we have also thermosets, which are also chemically bonded. But now back to amorphous and semi-crystalline. What is the main difference? In amorphous we have a random arrangement of the polymer chains, and we have one distinctive glass transition temperature. Up to this temperature we have good mechanical properties. From there on, once we are above it, we have a drop in the mechanical properties. And however, the processing window is bigger. On the other hand, semi-crystalline resins, they have ordered structure of polymer chains, which are referred to crystallites. This is, you can see here in the red circle. So it's really a nice alignment of the chains, and this results that we have glass transition temperature and the crystallization temperature, and the mechanical properties are above glass transition temperature, still better than in the amorphous morphology. However, the processing window is much narrower. Okay, when we have now a closer look at the amorphous resins in terms of properties, what we already mentioned, they have low shrinkage, low warpage. You can achieve tight tolerances in your final part, and you can also make transparent parts. However, when you look in filling your mold, they are not easy flowing. Chemical resistance is not as good as in semi-crystalline, and also the wear resistance is also not the best. And those are the 3 points we will focus in this video. How to improve the flow into the mold, how to improve the chemical resistance, and also how to improve the wear resistance. Then in semi-crystalline, they have high shrinkage, warpage, tight tolerances are more difficult to fulfill, as well as transparent parts, so the majority is opaque. However, you can make, for example, there are polyamides where you can make them transparent, and also for example polypropylenes with a certain additive which make the crystallites so small that the light can come through and you still have a transparent part. Strength are easy flowing, so molds are easy filling, easy to fill. Chemical resistance is high, and also the wear resistance. Okay, so now key question is it possible to increase the flow and the chemical resistance of amorphous resins? Short answer is yes, it is possible. And now we have a look how we can do this. So one way to do this is by alloying with other material. In most cases with a semi-crystalline material. So I have here as example polycarbonate. I have here some selected properties, some mechanical properties, impact properties, thermal properties. And here when you look at full resistance, melt flow, full resistance is poor, and also the melt flow is also poor, and those are two properties we want also to improve. So one way is we can go to PC-ABS blend. There we can increase the melt, so we have already a better melt flow. We have also the impact over the temperature range, so -40 to up to 120 is improved, and however the full resistance is still poor. So what we can do is we can exchange the ABS with an PPT, and with that we can increase the full resistance. In a I would say, fair level. So it's not the best, but however, it's sufficient enough to be used, for example, in automotive, in exterior parts or clothes. Like, for example, when you think of the lawn mower tractors, you can make the housing of the engine and some parts, because you need this high impact behavior, you need the tight tolerances. It's huge parts when you think of such housings. So shrinkage, warpage control is here really important. So and you need also good flow, because it's big parts, you have long flow ways, and that together we have then fair full resistance together with a good melt flow to fill such big parts. And then the third question we want to answer is how can we improve the wear resistance? And the wear resistance of amorphous resins. Short answer, yes, it is possible to increase the wear resistance of amorphous resin, that we can use them in parts such as gears, as shown here. So how we can do that? With PTFE lubrication. So once again, I've selected the polycarbonate. We have here the wear factor and the dynamic coefficients of friction shown. So you can see here 0.6 and 560. So, and that in acetal, so POM, which has really good wear factor, so just 90 compared to 560, and coefficient of friction is also lower. So POM is a really good material for gear application, for example. However, when we add now polycarbonate with additive, some low amounts of PTFE for lubrication, then we can decrease the wear factor. So we will not reach the POM level. However, we can really significant decrease it, and also have a coefficient of friction below that one of POM. So in this example, it's polycarbonate with PTFE 15%. Okay. If you want to have more information on polymer engineering topics, I highly recommend you my blog findoutaboutplastics.com, as well as on material selection, my online courses on the Thinkific platform. I will link you both the blog and the courses in the description below. Okay, which video to watch next? In this video I discuss how to improve the dimensional stability of semi-crystalline resins to allow them to be used in parts which need to have extremely tight dimensional and need to be flat as well. Thank you for watching, and do not forget to subscribe and smash that like button. Till next time, bye.